topic is practice questions of strength of material. Topic is simple stress and strain. Okay. First question is two identical circular rods of same diameter and same length are subjected to same magnitude of tensile stress, tensile force. One of the rod is made out of mild steel having modulus of elasticity of 206 GPa and other rod is made out of cast iron having the modulus of elasticity of 100 GPa. Assume both the material to be homogeneous and isotropic and axial force causes the same amount of uniform stress in both the rods. The stress jolt are within proportional limit of respective material. Which of the following observation is correct? A. Both rods elongate by same amount. B. Mild steel elongate more than cast iron. Cast iron elongate more than mild steel rod. As the stresses are equal, strains are also equal in both the rods. So, look at the answer. Let del Ci is the change in length in cast iron, and del Ms is the change in length in mild steel. Then the change in length is P into L by A into ECI. E is 100, okay, for cast iron. P, A and L are same for both mild steel and cast iron. So for mild steel change in length, PL by A into 206 and for cast iron PLA by 100. Okay, so as 100 is less than 206, so change in length in cast iron will be more than change in mild steel as they both have to follow the Hooke's law because it is within proportional limit. Okay, so the next question is next question is a steel bar of 40 mm into 40 mm square cross section is subjected to an axial compressive load of 200 kilonewton. If the length of the bar is 2 meter and E is 200 GPa, the elongation of the bar will be. So this is a simple question. The load is 200 kilonewton. Area is 40 into 40 mm square. Okay. The stress will be P by A and strain will be P by A into by E or change in length will be multiplied by L. L is 2 meter. So del L will be equal to putting the values P is equal to 200 into 10 power 3 and L is 200 10 power 3. A is 1600 mm square and E is 200 10 power 3. So it will be negative because load is compressive. So answer will be minus 1.25 mm. Okay. Next question is two stress and two strain. A steel bar of 50 mm, 50 into 50 mm square, cross section is subjected to an axial tensile load of 200 kilonewton. If the length of the bar is 2 meter, E is 200 GPa, the value of Q strain is okay. This is in within elastic limit. Okay, value of Q strain you can find. First, we have to find out the normal strain or conventional strain, which is nothing but P by conventional strain P by A is 15 to 15 and E is 200 into 10 over 3. So it comes out as 1 by 2, 4500. Okay, the true strain now the true strain and the simple strain relationship using true strain and simple strain relationship we can find out epsilon t ln 1 plus epsilon ln 1 plus 1 by 2500. Okay, it is so epsilon t is 1 by 2500.49. Okay, the idea for this question is to cramp the formula for true stress and sorry, true strain and simple strain. So in above question, the value of true stress. So in this question, we have to remember the relationship between true stress and simple stress. So the relationship is sigma t sigma 1 plus epsilon. We have to put sigma is equal to 80. Okay, because normal stress is load by initial area, which is 80 MPa, and normal strain is 1 by 2500 as we have found out. So the normal to stress will be sigma t 0 30.0232. So here we can see that the value of true stress at simple stress is almost same within elastic limit. Okay, and it takes a change after the elastic limit. Okay, so there will be not reduction in area. So next question is a metal rod of initial length L0 is subjected to a drying process. Okay, the length of the rod at any instant is given by the expression Lt is equal to L0 bracket 1 plus t square bracket close, where t is the time in minute and true strain rate at the end of 1 minute. Okay, so what is true strain rate? True strain rate will be uh, strain per unit time. Hmm? Strain per unit time. Okay, so this is the expression for length L is equal to L naught L naught 1 plus t square differentiating dl by dt. dl by dt is change in length per unit time. Okay, so it will be 2t L naught 2t L naught. Now if we divide this two, sorry, divide dl by dt by L or instantaneous length, we can find out strain. So dl by L is strain and dt is strain rate. So putting the value of L is equal to L naught 1 plus t square 2t 1 plus t square. So this is dl by L is true strain d epsilon t by t 2t 1 plus t square 2 epsilon t by dt t is equal to now at time t is equal to 1 minute or after 1 minute the strain will be 2 by 2 1. Okay, next next question is stress strain curve. Question number 6. The stress strain curve for milestone is shown in figure below. Choose the correct option referring to both the figure and table. Points on graph P, Q, R, S. Description is 1 upper yield point, 2 ultimate tensile strength, 3 proportional limit, 4 elastic limit. Straightforward question. P is our P is our proportional limit. Okay, so it is 3. Q is our elastic limit. Q is 4. R is our upper yield point and S is lower yield point. R is upper yield point, S is lower yield point. T is ultimate strength point and U is okay. T is ultimate strength point, U is okay. And U is okay. Next, which one of the following types of stress strain relationship describe the behavior of brittle material as ceramics or thermoplastic? So it is also a straightforward question. As ceramics are the brittle material, so for brittle material, D option D graph is right. Okay. Next question is on strain energy stress strain curve. The stress strain curve of a material is shown in figure. The resistance and toughness in Newton meter per meter cube are respectively. As we know, the resistance is the strain energy stored per unit volume up to elastic limit. So area up to this point or the area of the triangle, this triangle will give resilience and area of the hole uh, from this point to this point will give toughness. So you can find out the area. So resilience is area AOC. The base is 70. Uh, perpendicular is 70 and base is 0.004 and area of triangle is 70 by 0.004 into 10 to the power 6 is 40 into 10 to the power 6. So, so now toughness is This area OAC plus ABDC. 14 over 6, 120 minus 70, 120 minus 70, okay, by 2, 120 minus 70, 2 is for area of triangle, and the area of triangle, area of this triangle. A, and base is 0.012 minus 0.004 and 6. Okay, and area of rectangle, this rectangle, 17 10 over 6 into 0.012 minus 0.004. Okay, so if we sum all this, it will be 19 over 6. Okay, so the next question is, a mild steel specimen is under uniaxial stress. The Young's modulus and yield stress for the material for the mild steel are 2 into the power of 5 MPa and 250 MPa respectively. The maximum amount of steel energy per unit volume that can be stored in this specimen without permanent set is, okay, maximum amount of stored energy without permanent uh, deformation is resilience. So we just have to take the yield stress, okay, uh, because we are taking the yields and we have to therefore permanent deformation start. Okay, then this stress into E by 2 is your resilience or strain energy stored per unit volume. Okay, area of stress is curve. So this is stress 250 to 250 by 245 by 2. 250 is for sigma into stress into stress. Sigma square by 2 is sigma square by 2 is sigma is 250 0.156. 250 MPa means 250 into 10 raised to the 6 Newton per meter square by Newton per meter square. Next question is, this is the last question for today. 10th question. The flow stress in MPa of a material is given by sigma is equal to 50 epsilon point 1. Okay. Where epsilon is the true strain. Okay. The Young's modulus of elasticity of material is 200 GPa. A block of thickness 100 mm made of this material is compressed to 95 mm thickness. Then the load is removed. The final dimension of the block is in mm is, so as the as the initial thickness was 100 mm and final, and when the load is removed, the thickness was 95 mm, because the permanent deformation, some amount of permanent deformation takes place. Okay, so the material will not gain 95 mm thickness, neither gain 95 mm thickness. or nor gain 100 mm thickness. Okay, so the stress strain relationship is sigma is to 500 epsilon is. Here the epsilon is the true strain. The, the true strain uh, is given by ln final initial by final. Okay, or we can say final by initial. It will be negative. Okay, then its value will be 0.015129. Okay, from this we can find out true stress because here the sigma is true stress and epsilon is also true stress. So this is true stress. Okay, so when the load is removed, then it will follow the linear relationship and the stress strain and follow the Hooke's law. Okay, because sigma t amount of stress has been worked on it. Okay, and it will release this stress and will free. So the sigma t, so the simple, so the material will follow Hooke's law. Okay, sigma t by E is your strain and the change in length will be 0.1764. Okay, now the material has to come back to its, will try to come back to its initial position. Okay, as the load is removed, it will deform by according to linear relationship. Okay, because of strain hardening phenomena. Okay, so del L will be 0.1764 because compressive stress has been removed from it. Okay, so the final dimension will be 95 plus 0.1764 because initially it will compress to 95 mm and then the stress will be released. Okay, compressive stress will be released or we can say tensile stress can be applied. Okay, so the final answer will be 95.1764.